50% of people who are blind drop out of high school. 70% are unemployed. Over 90% are unable to read and write Braille. Our device poses a cheap solution to learn to read Braille. Our team is composed of two people, myself and my friend Eden Srivastava, being a computer science and econ major, respectively. Braille readers are extremely overpriced for people who are blind to be able to afford. They range anywhere from $3,000 on the high end to $650 on the low end. The lower end devices only being able to read from SD cards. You can see that for a highly unemployed population, this would be very difficult to acquire without external funding. The device we have created, which we have dubbed the Enigma Braille Reader, is set to cost only $25 for the first initial sell and will be able to expand on this axis, costing only $10 more per cell. The parts consisted in this device are mostly 3D printed and laser cut, so they would be simple for someone to make and distribute. The design itself is intended to be open source and uses a common serial protocol to address, so that anyone who wants to develop new integrations for the device and create new ways to learn Braille will be able to do so to increase the Braille literacy rate. So moving on from the CAD design to the physical prototype we created, the first thing you'll notice here is we cut the panels out of clear acrylic on a laser cutter. And so we did that so you'd be able to see inside and see the mechanism really easily. And so starting with the electronics, we used an Arduino Mega. We're not nearly using the full capability of the Mega here. We could just use an Uno, we just happen to have one lying around. We also have a power module down here at the bottom. This distributes the power evenly between the Mega and the two servo motors here. And so for the actual mechanism itself, we 3D printed the gears here at a 2-to-1 ratio out of a PLA plastic, as well as the actual spinners themselves. Since they have really tight tolerances, we resin 3D printed those just to get those bumps really clear. That wouldn't be possible with the plastic 3D printer. We also colored the dots here on top so you'd be able to see those really nicely. So one downfall we did have while creating this was we didn't have some nice flat head screws with a little slanted edge on the side. So our heads are sticking out and sometimes they like to rub and jam up the mechanism. But a good portion of the time it works really well.
And looking at the software side, this is all programmed in Arduino C, and the bulk of the programming is made to be extendable in order so that anytime we change the design or the gear configuration of the Enigma, we're going to be able to automatically have it being backwards compatible. Now we're moving from a 180-degree shift on the servo down to basically 8 degrees of freedom. The reason for the 8 degrees of freedom is this Braille spinner that's been going this entire time. These Braille characters are 2x3, and what we've done is split them down the middle so that way we can have permutations of 3, meaning we've got 8 different states. That makes it a lot easier to read out, and this is all within the Braille standard for what we have. Right now, you can send any serial character to it and it'll output it. Otherwise, right now we just have it rotating from A through Z and 0 through 9 in special characters. We did do bit shifting in this as well too to save memory, so then that was a great way to ensure that as we expand out different modules on this axis, it'll be perfectly great to be extendable. And that's our project. Thank you.